Hello everyone, I welcome you all in the C programming and data structures lecture. From this presentation onwards, we will see some applications of stacks, and in this particular presentation, we'll see one such application of stacks, that is nested brackets. This is part 1 of application of stacks, nested brackets. So without any further delay, let's get started. This is the problem statement. Write a program to check the validity of the expression containing nested brackets. Now this is quite interesting. We want to write a program to check the validity of the expression containing nested brackets. Now what do we mean by checking the validity of the expression containing nested brackets? This means that we have to check the total number of left brackets must be equal to the total number of right brackets. This is a very important condition. If we want to check the validity of the expression containing nested brackets, we must check this whether the total number of left brackets are equal to the total number of right brackets or not. And there is one more condition we need to check. For every right bracket, there must be a left bracket of same type. This is also very important. We must also check this. For every right bracket, we must have a left bracket of same type. If it is not the case, then we can say this, that the given expression is not valid. If any of these conditions are not satisfied, then clearly we can say this, that the given expression is an invalid expression. Now when I'm saying bracket, actually I mean 4 different types of brackets. We have round brackets, we have square brackets, we have curly brackets, and we have angle brackets. In an expression, it might be possible that we have only round brackets, only square brackets, only curly brackets, or only angle brackets. Or it might be possible that we have combination of these brackets in an expression. So these are the types of brackets that we will consider in an expression, and we will check the validity of the expression containing these brackets. This means that we must check whether the total number of left brackets are equal to the total number of right brackets or not. Along with this, we must also check this, for every right bracket there should be a left bracket of same type. Now let's see some examples of some invalid and valid expressions. Here is the first example. Let's say we have this expression a minus b plus c. You can see this, that in this particular expression, we have 2 types of brackets. We have square brackets and we have round bracket, right? Here you can see this, that the first condition itself is not satisfied. The total number of left brackets are not equal to the total number of right brackets. You can see this over here, we have just 1 left bracket, and here we have 2 right brackets. It is clear that this expression is invalid. As I've already told you, if any of the condition is not satisfied, then we can say that the expression is invalid. First condition itself is not satisfied. The total number of left brackets are not equal to the total number of right brackets. That's why this expression is invalid. Now let's see one more expression. This expression is obviously valid. Why am I saying this? You can see this, that total number of left brackets are equal to the total number of right brackets. Here we have 2 left brackets and 2 right brackets. Along with this, for every right bracket, we have a left bracket of same type. You can clearly see this. Here we have an opening square bracket and we have an associated closing square bracket as well. Along with this, we have an opening round bracket and a closing round bracket. It is clear that this expression is a valid expression. Let's see one more expression. Here you can clearly see this, that this expression is invalid because for this opening round bracket, we do not have a closing round bracket. Hence this expression is invalid. And this expression is valid because here both the conditions are satisfied. Total number of left brackets are equal to the total number of right brackets. Along with this, for every right bracket, we have an associated left bracket of same type. Hence this expression is a valid expression. Can we say this, that this expression is a valid expression? Of course not. You can see this, that first condition is satisfied. The total number of left brackets are equal to the total number of right brackets. But here you can see this, that we have an opening round bracket and here we have a closing curly bracket. These two are not of same type. Hence we can say this, that this expression is invalid. Correct? Now let's see one more expression. This expression is obviously valid because here we have only 2 brackets. One opening round bracket and one closing round bracket. Hence this expression is valid. We are done with all the examples, and now I hope it is clear to you how to check the validity of the expression. If someone gives an expression to us, it would be easier for us to identify whether the given expression is valid or not. We already know the rules. We just have to apply the rules. Here of course you can see this, that the first condition says that the total number of left brackets must be equal to the total number of right brackets. We already know the meaning of this. Here you can see that this expression is invalid because the total number of left brackets are not equal to the total number of right brackets. But this expression is valid because this condition is satisfied. Along with this, when we say that for every right bracket there should be a left bracket of same type, we actually mean that the types must be same. Here of course this expression is invalid because the types are not same. Here for this opening round bracket we do not have a closing round bracket, instead we have a closing curly bracket. The types are not same. Hence we can say this expression is invalid. But this expression is perfectly valid. So these two conditions must be satisfied if we want to say that the given expression is a valid expression. Now before writing a program to check the validity of the expression, it is a good idea to write the algorithm first. Then we will convert that algorithm to its equivalent C program. It is always a better thing to do. Let's first write the algorithm. First, we have to create an empty stack. This is very important. Then we have to scan the symbols of the expressions from left to right. Okay. After this, if the symbol is a left bracket, then push that symbol onto the stack. Okay. If the symbol is a right bracket, then we have to do the following. That is, if the stack is empty, then we must print invalid expression, that is right brackets are more than the left brackets. Otherwise, we must pop an element from the stack, and if the popped bracket does not match with the right bracket, then we must print invalid expression, mismatched brackets. Don't worry about the execution of this algorithm. Just focus on the steps. Here we first have to create an empty stack, then we must scan the symbols of the expression from left to right. If the symbol is a left bracket, then push that symbol onto the stack. If the symbol is a right bracket, then we have to do the following. If stack is empty, then we must print this message invalid expression, right brackets are more than left brackets. If it is not the case, then pop an element from the stack, that would be a bracket. If the popped bracket does not match with right bracket, then print invalid expression, mismatched brackets. If it is not the case, then we'll continue to scan the symbols of the expression from left to right. Okay. After scanning all the symbols of the expression, we must check this if stack is empty or not. If it is the case that stack is empty, then print valid expression, brackets are well balanced. Otherwise, we must print this message invalid expression, left brackets are more than right brackets. Let's consider one example and let's try to evaluate this algorithm line by line and see how this algorithm will help us in checking whether the given expression is valid or not. Let's say we want to check whether this expression is valid or not. We have this expression a divided by b minus c into d plus e, and we have a combination of some brackets in this expression. Our task is to actually check this whether this expression is valid or not. For this purpose, we need a stack data structure. That is why, according to the algorithm, we first have to create an empty stack. Here you can see this that I have created an empty stack, and obviously this empty stack will help us in checking whether this expression is valid or not. Let's see how. We have to scan the symbols of the expression from left to right. This is according to this algorithm. We have to scan the symbols of the expression from left to right. You can see this that the first symbol that we have encountered in this expression is actually a square bracket. We must push this square bracket inside stack. Now why we are doing this? This is according to the algorithm. If the symbol is a left bracket, then push that symbol onto the stack. You can see this that this is a left bracket, right? And to be precise, this is a left square bracket. We must push this square bracket inside stack. Okay. Now, after pushing this left bracket, we must continue to scan the rest of the symbols. Okay. You can see the next symbol is letter A. Obviously, we must not push this inside stack because this is not a bracket, right? Therefore, we must continue and scan the rest of the symbols in this expression. Whenever we encounter a left bracket, we must push that inside stack. This is according to the algorithm. Okay. After A, we encountered this symbol that is division, and we must not push this symbol inside stack because this is not a bracket. After this, we have encountered this particular round bracket, right? This is an opening round bracket. Of course, this is a left round bracket. We must push this bracket inside stack. Correct? Now after this, we have letter B. We must skip this. We have minus. We must skip this. We must skip this as well. The next symbol is, of course, a right round bracket. Now what to do with this? We have a right round bracket. We do not have a left round bracket. We cannot push this symbol inside stack. According to the algorithm, if the symbol is a right bracket, then do the following. Okay. If the stack is empty, then print invalid expression, right brackets are more than the left brackets, but it is not the case. We have a symbol inside stack. Therefore, stack is not empty. Hence, we must evaluate this expression. That is, pop an element from the stack. We first have to pop the element from the stack. You can see that this is a closing round bracket, right? And here, the topmost element is an opening round bracket. It is clear that after this symbol, we must encounter this symbol if we want to say that this expression is valid, right? Also, please note this, that order does matter, okay? We have to check the order as well. It is very important that after an opening bracket, we must see a closing bracket of same type. Then only we can say the expression is valid. Let's say instead of this closing round bracket, we have a closing square bracket. Then this is not correct because recently we have encountered an opening round bracket. Therefore, it is important that we must see a closing round bracket. Here you can see we have a closing round bracket. According to the algorithm, we will compare this bracket with this bracket, right? If these two are matching, then only we can say the expression is valid. Otherwise, we won't say this, okay? The expression would be invalid. Therefore, order does matter. Apart from the two conditions, the total number of left brackets must be equal to the total number of right brackets, and for every right bracket, we must have a left bracket of same type. There is one more thing to check. The order, okay? If we encounter an opening bracket and immediately after that we have encountered a closing bracket, then the types must be same. Then only we can say this, that the current expression is a valid expression. Always remember this. Order does matter. It might be possible that in place of this closing round bracket, we have a closing square bracket, and here in this place we have a closing round bracket. You can clearly see this, that the two conditions are satisfied. The total number of left brackets are equal to the total number of right brackets. Here, let us suppose that this round bracket is replaced by square bracket, the closing square bracket, and here this closing square bracket is replaced by a closing round bracket. Then also we can say this, that the two conditions are satisfied. For every right bracket, we have a left bracket of same type. Along with this, the total number of left brackets are equal to the total number of right brackets. But the order is not correct. Here, after this round bracket, we must see a closing round bracket, but instead of that, we will encounter a closing square bracket. Definitely the given expression will not be a valid expression. Okay? That is why I'm saying that the order does matter. Because here you can see this, that this is the topmost element. We must pop this element out of the stack. And then after this, we must check this. If the popped bracket does not match with right bracket, then print invalid expression mismatch brackets. Here you can clearly see this, that popped bracket is actually an opening round bracket and right bracket is actually a closing round bracket. These two are matching. Isn't that so? They are matching. Why I'm saying they are matching? They are of same type. This is a round bracket and this is also a round bracket. It is clear that they are matching. Hence, we cannot say that this expression is an invalid expression up to this point. Okay? Therefore, we must continue to scan the symbols of the expression from left to right. Now we must continue to scan the symbols. Here, of course, after this round bracket, we have encountered this particular symbol star. Then we have this curly bracket, this opening curly bracket. This is a left bracket. We must push this inside stack. After this, we have D, we have plus, we have E. Then we have this closing curly bracket, or we can say this, that this is a right curly bracket. Now what to do with this? Of course, we have to pop the current topmost element from the stack, and we must compare this bracket with this bracket. Here you can see this, that popped bracket is a curly bracket and right bracket is also curly bracket. Therefore, they are matching. There is no doubt about this. Hence, we can say this, that there is no problem and we can continue. If they are not matching, then definitely it is a problem and we can say this, that the given expression is invalid. Now, I hope it is clear to you that how the algorithm is checking whether the given expression is valid or not. After this symbol, we have the square bracket, right? And of course, this is a right square bracket. We must pop an element from the stack and we must compare this element with this element. That means we must compare this left bracket with this right bracket. Here you can see this, that this popped bracket is actually a square bracket and right bracket is also a square bracket. They are matching. Hence, we can say this, that there is no problem. And of course, you can see this, that we are done with this expression, right? According to the algorithm, after scanning all the symbols of the expression, if stack is empty, then print valid expression, brackets are well balanced. Okay? total number of left brackets are equal to the total number of right brackets. Therefore, we can say this that brackets are well balanced. Previously, we were checking whether for every right bracket we have the left bracket of same type or not. Here we are checking is the total number of left brackets are equal to the total number of right brackets. I hope it is clear to you. If the stack is empty, then it is a clear indication that the total number of left brackets are equal to the total number of right brackets. There is no doubt about this. As we are done with scanning all the symbols of the expression and there is no problem in the expression, we haven't printed this message, right brackets are more than left brackets. Neither we print this message, mismatched brackets. Therefore, it is clear that we will print this message, valid expression brackets are well balanced. Of course, our stack is empty, right? You can clearly see this that stack is currently empty. Therefore, we can say this that the given expression is valid expression. Hence, we must print this message, brackets are well balanced. Correct? I hope now everything is clear to you. Let's consider one more example to help us better understand the algorithm. What happens if we have an invalid expression? Let's consider one more example. This is example 2. Let's say we have this expression with an opening round bracket and a closing curly bracket. This is a very small expression. According to the algorithm, we have to create an empty stack. Okay. First, we create this empty stack. After this, we have to scan the symbols of the expression from left to right. Correct? Let's scan the symbols of this expression from left to right. First, we have encountered the symbol that is left round bracket. We must push this particular symbol inside stack. Because if the symbol is a left bracket, then we must push that symbol onto the stack. You can clearly see this that this is a left round bracket. We must push this inside stack. After this, we must continue and scan the rest of the symbols. Here, of course, we have 3. We must skip this. We must skip this symbol also, and we must also skip this. After this, we have encountered this symbol that is a curly bracket. This is a right curly bracket. According to the algorithm, if the symbol is a right bracket, do the following. If the stack is empty, then we must print this message, invalid expression. Right brackets are more than the left brackets. It is making sense as well. If there is no symbol inside stack to compare, then definitely right brackets are more than the left brackets, making sense, right? Otherwise, pop an element from the stack and check this. If the pop bracket does not match with right bracket, then print invalid expression, mismatched brackets. Making sense, right? Here we know that stack is not empty, hence we will evaluate the else part. We'll pop an element from the stack, which means we'll pop this element out of stack, and then we will compare the popped bracket with the right bracket. That is, if the pop bracket does not match with the right bracket, then we will print this message, invalid expression, mismatched brackets. Of course, we can see this that popped bracket is a round bracket and right bracket is a curly bracket. They are not matching. Hence, we can say this that the given expression is an invalid expression. And we can print this message, mismatched brackets. Okay. So output is invalid expression, mismatched brackets. I hope now it is clear to you how the algorithm works. What happens if we have an invalid expression? Obviously, here in this case, we will get this message, mismatched brackets, because the brackets are not matching. It is not the case that the total number of left brackets are not equal to the total number of right brackets. The only thing is that the left bracket is not matching with the right bracket. Hence, we can say this, that the given expression is invalid, and of course, the reason is mismatched brackets. Okay friends, this is it for now. Thank you for watching this presentation.